If we've got time. If not, we'll try to make some time tomorrow, okay? Alright. Everybody got it cut and place it down? So here, let's talk about how we're going to number our homework. Okay? Because what on earth is the problem number? There's two things you're going to write down. Okay? Especially so you can go back and look at it. Okay? You might want to go over this problem again and go, I know we did this one in class, so I will need to find that problem. So you're going to write the year, 2013, and the problem number 5. Okay? When I assign a problem, I expect you to do parts A, B, C, or D, however many parts are there. Okay? All right. So, let's try to read. We're going to label the picture as we go. Okay? Half the battle is sometimes reading the problem. Okay? And again, on the AP test, you get to scribble all over the problem. You can write in there. I know it's harder to do with it on your screen. Okay? But again, I'm trying to save a little bit of paper. Okay, so we're going to let f be 2x squared minus 6x plus 4, and g is 4 cosine 1/4 pi x. Okay. This is going to be 41, yeah. So we're going to just do, the problems we do in class are going to become part of your homework. Okay, so that's how I'm going to see them. So you want to do them. Looking at those two curves, which one is the F curve? The one on the top or the one on the bottom? It's a parabola opening up, right? So it's got to be the one on the bottom, which means the other one is the one on the top. Do we get to use a calculator here? Problems 4, 5, and 6 are always non-calculator. Always, okay? Good news is look at, they gave us these intersection points, so I don't need to worry about those. They gave me them, okay? It's actually kind of nice to not be on the calculator. All right, so we need to find the area of R. When we do area, what do we have to do? What minus what? Top minus bottom is our kind of generic rule, right? So I'm going to label part A. Okay, so I can do part A right here. My top curve is what? Which curve? What's its name? G. So G of X minus, what's my bottom curve's name? F of X dx. What should my limits be? 0 to 2. Good. Now, technically right there, I would have earned a point for my integrand. Here's the problem. Aren't we integrating this by hand? So do I need to write these in? I'm going to have to write them in, right? So if it was a calculator problem, I would stop. That would be enough sufficient, and I could go put it in my calculator and get my answer. Okay? But I have to integrate by hand, so I am going to go ahead and substitute these guys in. So my g of x was 4 cosine. Instead of writing 1/4, I'm going to say it's pi over 4. It's the same thing. X. Minus my bottom curve, which is 2x, put it in parentheses, squared, minus 6x plus 4 dx. Okay. Aren't I going to need a u substitution in the front? So I'm going to pull this into two separate integrals. That's why I left that space in there. Because I know that I need a u here and I don't need the u in the back. Okay. All right, so what's my u going to be? I'm going to do my u work way up here at the top. Pi over 4 x. Good. All right. Du is then what? Dx. Do I have the pi over 4? No part of it, right? So I'm going to have to move that over to the other side. How do we move it to the other side? Multiply by the what? Reciprocal. Good. All right. I am just going to work on the left half. We'll come back and do the right half. Okay, so keep going down with your work. I'm going to have to slide it to the side a little bit because of the space that I have there. Okay. All right, so let's see. I'm subbing in my u. So we've got 4. What am I going to put in for this pi over 4x? U. For the dx, I'm putting in 4 over pi du. Notice I took my limits off temporarily. All right, what's 4 times 4? 16 over pi. When I integrate cosine, what do we get? Sine. Instead of writing u, what could I write? Yeah, can't I just sub back in? Yeah.
So you have to take off your limits, or just like you can't?
Technically, you probably should, because we would have to convert them to u's to leave them on there. I'm not sure they would look at that line. Okay, so if you left them on there, I'm not sure they would mark you down on that. Okay? All right, and then we're going to go from 0 to 2. I'm going to move this string of work up here. Okay, so I'm going to keep going here because I want to be able to write my other work underneath here. All right, so I'm plugging in those numbers. While I'm working on that, I'm going to work on that. Okay? So we've got 16 pi times sine of, let's see, what's pi over 4 times 2? What are we really going to get there? Pi over 2 minus 16 pi sine of, what's 0 times pi over 4? 0. Good.
Where do you get that line from?
This?
No. You're doing 16 pi. Yeah.
I'm taking these numbers and I'm plugging them into here. Okay. All right. Sine of pi over 2, you're thinking unit circle. We're talking, what, the top of the unit circle? Oops, out 0, up 1. I had it backwards. All right, so top of my unit circle, what's the sine of pi over 2? 1, right? So what's 1 times pi, 16 over pi? Good, 16 over pi. What's the sine of 0? 0 times 16 over pi is, I'm not even going to write it down. Okay, so I've gotten the first half solved. You're going to like parts C and B and C, trust me. Okay. All right, now let's integrate this other piece. I'm going to do it a different color so we can see it a little differently. So minus, I'm going to put parentheses. When I integrate 2x squared, what do we get? 2x cubed divided by 3. Perfect. Okay, when I integrate 6x, I get x to the second divided by 2. What's 6 divided by 2? 3. And then when I integrate 4, what do we get? 4x. And we've got to go from 0 to 2. All right. That was kind of with that line right there, right? So now I got to put this line here. So I'm going to start plugging in. Got minus. I'm going to keep my parentheses. What is 2 cubed? 8 times 2 is 16 thirds. What's 2 squared? 4 times 3 is 12. 4 times 2 is 8. I took and I plugged a 2 into all of this. Okay. Do I need to worry about plugging 0 in? It would cancel everything, right? If it was a 1, would I need to plug it in? Yeah, we'd have to plug it in. All right. So technically it's minus this mess and then minus, I'm not going to write it on that line, minus this mess again. On the AP test, you may stop here. Why would we stop there? What happens if I keep going and I mess up? Do I get the point? No. Do I get the point if I stop there, though? Yeah. So there is potential, and don't forget, you're going to be tired, okay? You will have already taken all the multiple choice questions, okay? Your brain's going to be hurting, okay? Just that's the nature of the beast. So the less potential you set yourself up for mistakes, the better. If we did it, I believe, let me look. I think it's 4/3. Yeah, 16 pi minus 4/3 is the answer if I actually multiplied that out, or found that, did all that work. Okay? So, on this one, we got a point for this. We got a point for each of the antiderivatives. So we got a point for this piece and this piece. Okay? And then we got a point for our answers. There were 4 points on part A. Okay? All right. Let's look at part B. Part B is magical. Okay? You want me to wait a second? Okay. The hard part about A is they're almost always on the area volume going to make you integrate the area. Whether it's on the calculator or by hand, they'll probably make you integrate it. Okay? But there's an upside to part B and C. Look at these. I took away my writing. Look at these magical words. Do I have to integrate it? I do not. Right? It says write, but do not evaluate. All I have to do is write the expression. Write the line of setup. Just like I was having you do on the test. You thought I was crazy last week, but that's all I want you to do. It's all they want you to do. Okay? All right, so I'm going to label this as B. So an integral expression that gives the volume of the solid when R is rotated about the horizontal line y equals 4. Draw that in there. Okay? So, we know that this one was F. I have to relabel because I lost my labeling. And we know that that's the line y equals 4, and I know I am rotating about the line. Okay. If that is the region that I am rotating, is this a disk or is it a washer? It's a washer because I am not touching, my region is not touching my line. There's a gap. Okay? All right, so let's talk about which would be the outer curve and which would be the inner. So is the x squared the outer or the inner? Outer, good. And then which one is the inner curve, closer to the axis of revolution? Yeah, so that's our inner, but we also have the top-bottom situation going on, and AP loves these. Okay? So, is the axis of rotation on top of the curves or below the curves? Top. So we know that that's going to be the top, and these are going to be the bottom. So now we have it labeled just like we would have had it labeled last week. Okay, on our little worksheets that I spit out of a test generator. This has way more words though, right? Okay, so let's see. We're doing volume. We're doing a revolution. How should we start? Pi. What should my limits be? 0 to 2, the x values, because you've got a horizontal rotation. If you write nothing but that down, you earn a point. Okay? We just got a point. In the answer or on the scoring guide, it'll say the limits and the constant. They're talking about the pi as the constant. Okay? All right, we know we've got a washer situation, so I know I've got to do 2 things squared with a dx after it. Okay? And let's see. So I'm going to work with my outer, but I got to do top minus bottoms. What's going to be the top for both of them? 4. So I'm going to do 4 minus something. Could I plop that in on both right now? All right. What's my outer curve? Does it have a name? So write f of x. Because what happens if you write this incorrectly? Are you going to get the point? No. Use the name if they assign it a name. They don't always assign it a name. In the next one, they don't assign names. Okay? All right. It's going to be top minus the inner curve was what? G of x. Done. That's it. You do not need to write the equations as long as you have the name, as long as they're named, right?
So can I just skip A and go straight to B?
Okay, Dante has a good question. Can he skip A and go to B? Absolutely. Okay? You guys, you do the parts you know how to do the best first. Okay? There's going to be times where part A, part B is awful, and for some reason part C is easy. Okay? Don't neglect part C just because you think it's going to be hard every time. It's not. Okay? Sometimes it's going to be easier. All right? So that's it. You got a point for this part and a point for that part. So you got 3 points total on that one. All right, let's try part C. Okay, I'm going to erase again. Only so you can kind of see my scribbles on there. All right, so region R, look at how nice this year was. For this solid, each cross-section perpendicular to the x-axis, so I'm going this way. We won't always go that way. In fact, we'll see one today that doesn't. What shape did they have to do? They got very lucky. Okay, they got a square. Magical words, do I have to integrate? No, we want to look for those magical words, right? Those are our favorites. All right. That gives the volume of the solid. All right, so I set this up a little differently. I kind of go through a lineage of making sure we know all the parts, okay? The AP test isn't going to show that in their scoring guide. They're just going to give you the answer, actually. All right, so I have to do the top minus the bottom for the side, right? So what am I going to write down for my top curve? G of x minus fx. Use the names. Because you're going to screw up the names less than you're going to screw up the functions. Don't neglect the of f of x part. Don't just write g minus f. Okay? At least try to get the notation proper. All right, for the area part of it, we would take this thing and what do we have to do to it for a square? Square it. So g of x minus f of x. All right. To do the volume, how do I get the volume from the area? We integrate. Should there be a pi? No, because it's a cross section. Okay? So I'm going to plop my exact area formula in here and throw a dx after it. On this one, oh, what did I forget? My limits. What are my limits? So you got a point for the limits and a point for the integrand. So you get 2 points on that part because the first part was worth 4. Okay? If I just did parts B and C, I get 3 points there, 2 points there. I've got 5 points. 5 points is really, that's passing. Okay? If you could earn 5 points on a problem, on each problem you pass the test. Okay? So that's a good number. All right? We're going to practice them over and over, so you're going to do really well. Okay? All right, we good with 13? Almost. Okay, write it down. All right. Let me go back to, I think it's 10 is the next one I want to do. All right. So the next one I want to pick up is I want to do 2010. Okay, so let's find 2010. So scroll to 2010 on your Chromebooks. Okay, because your picture, you'll probably be able to easier to read it off of yours than off of mine. Okay. All right. So we're doing volume and area again. Okay. In fact, you're going to look forward to the volume area question because you're going to be really good at it. Do we get to use a calculator? It's a question 4. No calculators. Okay. So it says let the region be the first quadrant bounded by y equals and y equals. Did they name it for us? Did they give us f and g this time? No. So we are going to have to write the functions. The functions really aren't that bad. And y equals 6. So what do they want me to do in part A? Find the area. You're going to notice that this area is actually probably easier than the other area was. Okay, so it just depends year to year what they decide to do. Okay? All right, so area is what minus what? Top minus bottom. Oh, did you guys cut it out and glue it in? I'm sorry. Take a minute, cut it out and glue it in. I should have paused. Find the picture on the page I handed you, cut it out and glue it in. All right, we ready? Almost. Top minus bottom. And then make sure you number it 2010 number 4. Okay? All right, here we go. You ready? So we're going to find the area of R. So let's see. What's our top curve? 6. What's the bottom curve? We're going to have to integrate this. Instead of writing square root of x, what should we write instead? Yeah, and AP will take that. Okay. What are our limits? Look at your x values. Yep. They gave us a square number on purpose because it actually helps us out. Okay. Okay. Let's go for the integral here. So when I integrate 6, what do we get? 6x.
Still 41?
Yeah, this is all still 41. Our goal was to try to do 5 today. We're going to only do a couple in class. The rest is homework. Okay?
We're doing 5 today?
We're going to try.
We got 10 minutes.
Okay. Well, like I said, we got through 2. We got through 2 0 periods. We'll probably do 2 this period. Okay. We have to add, right? So we're adding 1 to the exponent. What am I going to get as my new exponent? 3 halves, and I'm going to divide by 3 halves or multiply by what? So 2 times 2/3 is what? 4/3. Shh, you guys, let's pay attention. Okay. Okay. So I've got to put in the 9. I've got to put in the 0. Is the 0 going to matter? No, so I'm not even going to bother with the 0. I'm just going to work with the 9. What's 9 times 6? 54. Got to know your multiplication tables. Okay. All right. What is a better way to write 9 in here? Why 3 squared? The 2's are going to cancel. We're using some of our old algebra skills. Okay? Keep yours going straight down. Don't do what I have to do here. All right. What's 3 cubed? 27. And then 3 into 27, how many times? 9. 4 times 9 is 36. And my final answer is, isn't it 18? Okay. Technically, once I'm numeric, I could stop. I could have stopped there and gotten all my points. Right here where I boxed. I could have stopped there. I kept going. That's the answer they show on the page. Okay, and it really isn't that bad. But you want to make sure that you don't make a mistake. Okay? If you're going to keep going, you need to double check your work. On this one, the point was for a point for the integrand, a point for the antiderivative, which was that piece, and then a point for the answer. Okay? All right, let's keep going through B. Okay? What magical words do we see? Right, but do not evaluate. That's awesome. That means all I've got to do is set it up. Okay? An integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. I would be drawing that line in, so I knew where it was. So it's got to be, I'm rotating around there. It's y equals 7. I know this was the 2 square root of x, and this is 6. Okay. All right. Is it a disc or is it a washer? Washer. Okay, so I know when I go to set up, I've got to do something squared minus something squared dx. Okay. All right. So which one is my outer curve or my outer ring of my circle? Yep, so there's your outer. What's going to be your inner? 6. Good. Okay. But I have the top-bottom thing going on again, right? So is the axis of revolution on top or on the bottom? Top. So I know that's my top, and these two guys are my bottom. Good. All right. What's the first thing I should have written down here? Pi. What are my limits going to be? 0 to 9, the x values, not the y values. You get a point just for that. Okay? All right. How am I going to start this? 7 minus something on both of them, right? Okay. My outer curve is what? Good. My inner curve is what? AP doesn't even simplify that in their answer key. So should you?
No.
No. Done. That is it. See, isn't the AP test awesome? We don't even... What other test are you going to take that you don't even have to solve the problem the whole way? Okay? So you get a point for each one of those. So 3 points on that part. Okay? All right, the next one we haven't seen before. We've seen cross sections, but we haven't... There's 2 new things on this next one. Okay? We're going to do it together. We can do it. It's not that bad. Okay. Looking at part C. They say we've got R as the base of a solid. For each Y, notice, they changed your limits. They explicitly told you right there that you're now going this direction. Okay? They tried to warn you. Okay? All right. Cross-section is taken as perpendicular to the Y-axis. We've only done X-axis so far, haven't we? We really focused on that. All right? I'm going to show you how to do the Y-axis right now.
Can you put that line anywhere?
This line, yeah, put it wherever you want it. Okay, and I know your picture's getting messy because I've gotten to change my picture every time, right? And you haven't. You could always try to resketch it. All right. What shape are we doing this time? That's not one of the ones on our list, right? A rectangle. Okay, so let's talk about a rectangle for a minute. Draw yourself a nice little rectangle. Rectangles are, what's the formula for the area of a rectangle? Base times height. Good. Okay, so we know we've got a base, we know we've got a height. Let's keep reading. Whose height is 3 times the length of its base. So I know the height equals 3 times the base. If I was going to find an area formula for that, wouldn't I multiply this base times 3 base? So what's my area formula for that? Is there going to be just one formula I can memorize for a rectangle? Couldn't I keep changing the length of the height? So the height, you got to kind of be flexible with that. Okay? So you have to kind of create your own formula on this one. So on this one, I would have probably gone with trying to get A and B, right? C is a little bit more difficult because there's extra kinks in the road. Okay? All right, here's our magical words. Do I have to integrate it? No, we would need to find the volume of the solid. All right, so the first thing I'm going to do is find my side length. In this case, we're calling our side length base, right? Ooh, but here's the problem. I went the other way, didn't I? When I go that way, don't I have to be in terms of y, not in terms of x? So I need to take this guy here, and I'm going to solve it for x. So I got to get x by itself. I'm doing my work in that corner so you can see it. How do I get 2 to the other side? Divide it. Good. How do I undo the square root? Square it. So we got to square this side. So we have y squared over what? 4. That's our function, right? We just renamed our function in terms of y. All right, so my base is y squared over 4. Okay? All right, so let's talk about the area. Remember, it was the side length or the base length now, the area, then the volume, right? That's how we've been writing it down. So what would my area be? 3, what are we going to do to this, whatever we put in there? Square it. So y squared over 4.
You don't have to do it with the 6.
No, because we're not, notice we're going perpendicular to the y, not the x. Okay, so that's why the 6 got knocked out. Okay, the 6 is going to come back here in a second, isn't it? Because look at where you have to integrate. That's where the 6 is going to come in. All right, how do I get from area to volume? You're going to integrate. So we're going from, okay, what are my limits? Should I be putting a pi? No. Do I need to actually square the 2 and square the 4 in there? No, you can write it exactly the way it looks. Make sure it's a dy, not a dx, okay? All right. That's it. Done. Yeah.
Go over
So, yeah, just part C? Yeah, that's fine. Okay, so we want to watch. They changed our limits. That was a big hint. Something else is going on with this one. Okay. I looked at that it was a rectangle. So I know rectangle's base times height. They told me the height is three times the base. So I created my area formula from that. Okay. Then I had to, since it was perpendicular to the y, not the x, I had to solve my original for x squared, so I got it in terms of y. That was what that work was. So I know my base length was that new function. I took my new function, I plugged it into my area formula, and then I integrated my area formula. Okay? All right. That's where I'm going to stop today. Okay? But you need to finish